Okay. I'm rather bad at titles. Namely, I give one title, and then when I sit down to write up the talk, I don't bother to look up what title I gave. And there is a difference, which was that I promised to argue that humans aren't minds, and it seems like I'm going to be arguing that that minds are not machines. That humans are not machines. There's a set of arguments one could give that I'm not going to talk about, but I'll just quickly sketch them. Humans are animals. No animals are machines. Right? There's more to animals than machines. Machines are tools designed for a specific purpose. They have no value in themselves. They're purely of instrumental value. Animals are not like that. Animals have a life of their own, and especially human animals do. So no animals are, I think, machines. So that would be an argument that humans are not machines that applies across the board to animals. But I want to focus on, in the theme of AI, the mindedness of humans and argue that that gives us reason to think we're not machines. So our life as beings with minds has a number of puzzling phenomena, puzzling to philosophers, puzzling to scientists, puzzling to the ordinary person. Perhaps the most famous as of the 20th century and 21st is consciousness, right? It's a very puzzling phenomenon. There is a point of view we have. There's an inside view. We can see from the inside. There's something private about it. I have it. Maybe God can see what I'm conscious of, but everybody else can only see the external signs of what I'm conscious of when I report it in my words and in my behavior, and perhaps you can see neural correlates of it, but the consciousness itself, the specific way things look, to me, that is private. We make assumptions that it's kind of like what you see, but this is an assumption we make. There's a sense in which consciousness as such is a scientifically inaccessible phenomenon. It's an inextricably subjective phenomenon, and science studies what is objective, what is, or at least intersubjective. Well, consciousness is not. So it's a scientifically inaccessible phenomenon, which is strange, which seems to set a limit on science, but I'll argue more about this. A second very puzzling phenomenon is that of meaning. So some physical objects in the world have a meaning. For example, there's like pixel arrangements there that have a meaning, right? That finger here has a meaning. It means Stephen, who so graciously invited me and has organized this wonderful conference, right? So some physical things have a meaning. Physical things that have a meaning, it seems they get their meaning from something else. So, for example, the text here gets its meaning from various social conventions. We use words, and we introduce new words. How do we introduce new words into our language? We introduce them by using other words or using gestures. We use them, so we introduce things. We introduce things with meaning by using other things with meaning, right? So in mathematics, we often define our terms precisely, and we define them in terms of other words. We define what the word group means in terms of other words. We define those in terms of others. We define some things we don't have definitions of. Nobody has actually gone and defined an elephant, but we define them by pointing, which is another gesture, another physical thing with meaning. It means that thing that proceeds from this part of the most relevant thing in the ray, along the ray, starting here and going through here, or something like that. But this leads to a regress, right? Things with meaning get their meaning from something else with meaning. They get their sense, they get it from something else. And it seems that physical things just don't have a meaning in themselves, right? I mean, apart from our conventions, that stuff up there would be completely meaningless. And we could easily imagine beings where this gesture means me. The pointing goes like that, right? There's nothing intrinsic about pointing, or it could go, at 90 degrees off. Or it could be a way of exhibiting a finger or something else, or it could be a root gesture or something. So it doesn't seem like anything physical can have a meaning, and yet our thoughts and our words have a meaning. So they must get it from something not physical, it seems. Here's a suggestion. Maybe they get it from our minds, and maybe our minds are not physical. It's a possibility. Another ingredient of the puzzlingness of our mental life is free will. I'm not going to talk about that. We've had a great talk on that this morning. And another one is personal identity, which includes at least, I think, two factors: who we are across time and who we are across space. Where are my boundaries? And I will talk about the boundaries across space towards the end. Okay. Philosophers have a ton of different theories about what minds are. Three seem to be the main ones. The classic theory, going back to Plato, is dualism, that there are physical things, and then there's mental stuff, like a soul, or some non-physical properties, like consciousness, that some physical things have. So dualism holds that there's two kinds of things in the real world. There's physical things and non-physical things. And the mental stuff that goes on involves, at least to some degree, non-physical stuff. Biologism, it's not, I think, a standard term, says that minds are very specific kinds of biological organs. They are brains. So they are biological organs who have biological purpose. And what makes them minds is being the biological organs they are. There are kidneys, there are brains. Kidneys are not responsible for mindedness, brains are. And then probably the most popular view in contemporary English-speaking philosophy is functionalism. On this view, minds are machines defined by their function. Computational machines is the usual view. So I'm going to argue against both biologism and functionalism, though if I'm just trying to argue that minds are not machines, biologism is fine. So, let's do this. First, a general argument, and a lot of this is things that a number of different philosophers have come up with in the late 20th century. So, Frank Jackson, this is an argument against both biologism and functionalism, gives us this lovely thought experiment. Imagine Mary, who's a brilliant neuroscientist, and she knows all the relevant neuroscience about vision, and she knows all the physics of vision. And yet she's raised herself in a black and white environment. She has never seen anything colorful. She maybe has no color sensors in her eyes, or maybe she's always wearing glasses active goggles that turn things monochrome. But she knows all of neuroscience and physics. She doesn't know what other people are experiencing when they experience red. She knows exactly what happens in their brains when they're experiencing red. She knows exactly what's happening in their retinas when they're experiencing red. She knows all there is to know about the physics of light, of the relevant wavelengths. But she doesn't know what it's like to see red. I mean, kind of one way to get yourself into thinking this is, look, she doesn't know what it's like to see red. She doesn't know what it's like to see green. I mean, how does she know which one is which in her black and white world? She doesn't know. which experience would be which. If she suddenly got an experience of one or the other, she wouldn't know which one it is. So there's something she doesn't know, Jackson says. She doesn't know what other people are experiencing when they're experiencing red. So she doesn't know something. Wait, but she knows everything about physics and neuroscience. So that means there's more to experience than physics and neuroscience. So there's something more than the physical. Conscious experience goes beyond the physical. So this is an argument against both biologism and functionalism. Biologism is not as popular as functionalism among philosophers because biologism ties mind to a specific kind of physical substrate, some kind of specific kind of thinking stuff. So, namely brains, which are specifically human kind of organ. I mean, if we met aliens who had a completely different biochemistry, I don't think it would be correct to say they have brains any more than it would be correct to say they have kidneys. They have something maybe analogous to brains and something analogous to kidneys, but it wouldn't be brains and it wouldn't be kidneys. I mean, there would be a completely different evolutionary history to them, and those organs wouldn't have a shared evolutionary history of our brains and our kidneys, and with a different biochemistry, it would function very differently. We have a little bit of a model of this with things like octopi, which people do talk of octopus brains, but really it's not exactly a brain. It's a different kind of decentralized neural system that diverged from ours 600 million years ago. But if we met aliens, and no matter how different their biology was from us, no matter how decentralized or more centralized than ours, whether it was based on carbon or whether they were plasma beings on the surface of a star or something, as science fiction authors sometimes speculate about, if their social behavior and linguistic behavior was like ours, we would conclude they have minds. We'd be quite confident that they have minds. Maybe we wouldn't be 100% sure, but we would be pretty confident. But they wouldn't have brains exactly. So minds are not brains, because they would have minds without having brains. They would have something else, some other organ. So that makes, I think, biologism implausible. So biologism doesn't fit with this idea that people call multiple realizability, this intuition that we have that minds can be had but in a variety of different kind of substrates. Now, to a Catholic audience, this is actually kind of obvious because Catholics believe, look, in angels and God doesn't have a biological substrate except by virtue of the incarnation, and that's not his divine mind, that's the human mind that's involved there. And angels are usually thought of as immaterial beings. So minds can't in general be biological entities. It can't be that what it is to have a mind is to have a particular kind of biological substrate. It's also kind of worth noting that if it turned out that to have a mind, you had to have the kind of biochemistry we do and the kind of mind we do, it would make the fine-tuning argument for the existence of God more powerful, because God would have to fine-tune the world not just for things that function like we do, but that actually have the same kind of biochemistry that we do in order to have things with minds. So biologism, people are worried about because they're worried that it will not give aliens minds. And while we don't know that there are aliens, we have, I think, the strong intuition that there could be. What about functionalism? Functionalism is kind of an answer to worries about multiple realizability. It's a theory designed to make it possible for minds to exist in a very broad array of substrates, including perhaps even, though a lot of functionalists are materialists and maybe they don't even want to admit this, but it could even allow for minds to exist in a non-physical setting. So on this picture, a mind you can think of as a network of functional boxes. Each box has inputs, outputs, and some kind of a state that can change over time. So it's got some inputs coming in, It's got some rules in the box saying what happens. If the state's A and the input's 1, then it goes into state B and the first output maybe is 0 or stuff like that. So you've got a bunch of boxes like that. They're connected some of them to one another. Outputs become inputs. And some boxes are connected to sensors, global inputs, and some are connected to global outputs, effectors. Mental states then correspond to functional boxes having certain states. So maybe being afraid is constituted by some feature of boxes and the states that they have. The meaning comes from system inputs on usual functionalist stories. What makes a thought about flowers be a thought about flowers rather than about elephants is that the thought about flowers has a causal history that can be traced back to flowers rather than elephants. It gets a little more complicated than that, and nobody's actually worked out the details of how to do the more complicated kinds of cases, but that's the rough idea. We can give like a kind of toy model of what these stories, how these stories work. These are meant to be reductive stories about mental states, including conscious states. So you might have this story about pain. Okay, look, we've got damage sensors. The damage sensors put out data to some kind of box that records the fact of damage, which then processes it in some way, maybe quantifies it, I don't know, sends it to some kind of behavior decider box, which has other inputs, because of course pain is not the only thing that decides your behavior, because you sometimes critters withstand the pain they have and persevere in what they're doing, but sometimes it results in aversive behavior, and there's a kind of tendency for pain to result in aversive behavior. So a kind of toy model would be pain would be a state of a box typically caused by damage detection sensors giving outputs to a behavior decider tending to produce aversive behavior. Nobody thinks this is, I think nobody thinks this is actually true. I think everybody thinks the true model will have to be much more complicated than that. But the idea is it doesn't matter what's in the boxes, whether it's neurons, whether it's silicon, whether it's brass gears turning against one another, whether it's pebbles being moved around boxes. Doesn't matter what's doing it, as long as it has this kind of structure, it's a pain. So aliens made of completely different physics could be in pain just as much as we could be, as long as their behavior would be functionally similar to ours, and the internal causes had a kind of functional analogy to this. So the crucial concept here is of a functional isomorphism, where you could have two systems whose boxes correspond to one another, whose inputs and outputs correspond to one another, and which have the same rules governing the boxes, or analogous rules governing these boxes. And the functionalist says that if you've got two systems that are functionally isomorphic, over their lifetime, they have either the same or at least closely analogous mental states. So functionally isomorphic systems have very similar mental states. So if one feels pain, so does the other. I say very similar because there might be some little tweaks. Part of them have to do with the fact that meaning comes from the outside. So you could kind of imagine that they're embedded in a different environment and the triggers are different. And so the meanings of some things might be different. So maybe one means squirrels by a given thought, another means elephants by it if there's some really weird processing in their visual systems that makes them both come out the same on the inside. But let's not worry about that. It's analogous. And it's completely irrelevant how the functional boxes are implemented, and in fact, they could be implemented non-physically in principle if there was such a thing as non-physical things. A consequence of this view is that a computer simulation of a human brain thinks just like a human brain, because the computer simulation has all the same boxes. The boxes, of course, don't have to be box-shaped. They don't have to be, unified spatially. They could be scattered throughout a simulation. They could be bits of memory here, bits there. They're like subsystems that, and a computer simulation will preserve a functional isomorphism. So you get multiple realizability galore. You get the possibility of conscious machines immediately from this, because you could have a computer simulation of a human brain. A human brain's conscious, so its functional isomorph will also be conscious on this view. And on this view, minds are machines, and if minds are the central defining feature of us, then humans are machines as well. So I'm going to talk through some objections to this. Some of them are standard objections. Some of them are a little bit less common. I'll give 4 of them. So the first and probably most famous, Professor Shire mentioned John Searle's Chinese room story. I'm going to tell a somewhat different story. I think Professor Shire's story fits really well with the specifics of the diagram here, but maybe not quite how at least the philosophers have understood Searle's thought experiment. So the thought is something like this. Suppose functionalism is true. A native speaker of Chinese is a functional system. That functional system can be emulated in software. So let C be the software that emulates it, and I'll just use software to mean both the code and the data taken together. So there's some software, C, that when you run it, you're a native speaker of Chinese. Now, one of the things that you learn as you're learning how to do computer programming is how to run code on yourself. Right? You read a little bit of code and you think, what does this do? And what are you doing? Sometimes you kind of step through it in your mind. Oh, here I'm letting A be 7. I'm running through this loop. I'm incrementing here. You can kind of run the little bit of code in your own mind. That becomes impractical when the code's larger. You may need a notebook to do that. You may need to start making notes. Okay, A is 7 that I do a loop from. Then I add 1. I loop this a million times. Okay, I'm going to have a little notebook where I have a little space where it says A, and beside it I start writing 7, then I erase, I write 8. This is all going very, very slow and inefficient, right? But I can run any code on myself with the help of a notebook and a piece of paper. So I just need a printout of the code, and then I need a lot of paper and a pencil, and lots of pencils because they run out, and lots of erasers, and I can run any code and so I can run a simulation of a native speaker of Chinese on myself. So here's the idea. We imagine Bob. He's sitting there in this room. He's got this notebook, paper, basically practically infinite supply of paper, a pencil, eraser, and he is running the software for processing. I guess in this case it's supposed to be written Chinese. And he's getting inputs in Chinese and producing outputs in Chinese. But it's not just a simple lookup table, which it's really doing the same kind of processing that an actual native speaker of Chinese is doing, assuming that a native speaker of Chinese is just a computer. Okay, so that's what Bob is doing. If functionalism is true, then the system consisting of Bob plus notebook plus pencil understands Chinese. There are, in fact, it seems in the Chinese room, there are 2 different linguistic systems. One is Bob, who is an English system, and one is Bob plus notebook plus pencil, which is a Chinese system. If minds are machines, understood in a functionalist way, then not only does Bob plus notebook plus pencil understand Chinese and be able to simulate what it's like to talk in Chinese and fool people. Well, it doesn't really fool people given how slow it is. Like might take 1,000 years between input and output, but it's still neglecting that little technicality, it's not just that it produces the same outputs, it's that it actually understands Chinese, has the same mental states as a Chinese, a native Chinese speaker getting these inputs. If you pass Bob, but something's weird about this, right? So if you pass Bob a note in Chinese that says that his wife has died, he'll just going to write back in Chinese how grieved and distressed he is. But you'll see him, you'll see there's not going to be any change on his face from this, any more than when you passed him a note earlier asking what 3 + 7 was in words in Chinese. It's just he's going to be flipping his notebook and writing maybe some words to be sent off for an obituary. If functionalism is true, Bob plus notebook plus pencil feels grief. This a lot of people find implausible. A lot of people find it implausible to think that Bob plus notebook plus pencil feels anything. That there is a second point of view in the room besides Bob's monolingual English one. And so people often take this as a reductio ad absurdum of functionalism. I think really in the end, the functionalists just say, yep, that's what happens. Bob, notebook, and pencil do in fact feel grief. They perceive the same things that a monolingual that a Chinese speaker does. They think the way that the Chinese speaker does. That's just how it is. And it's just a kind of unfamiliar computational system. It doesn't look like a normal Chinese speaker, but it could be. Interestingly, Searle also suggests this variant that maybe you could Bob could internalize all the processing in his brain and could run this program entirely mentally if he had really good memory capacity. And then I guess the functionalists would have to say he's got 2 independent lines of consciousness that don't interact much with each other, a Chinese one and an English one. And again, a lot of people find that a reductio ad absurdum, but not everybody. Here's a second argument. I guess the Searle argument is one of the 2 classic arguments against functionalism. The Putnam one is another one. I actually think the Putnam one is more powerful because the Searle one relies a lot on our intuition that a guy in the Chinese room doesn't really, that there isn't a Chinese consciousness in the Chinese room. The Putnam one, I think, still relies on an intuition. All of these do, but I think on a more plausible one. So functionalism has no restrictions on what boxes can be. What counts as an input, what counts as an output. And Hilary Putnam argued that any sufficiently complex physical system, if you interpret it the right way, can be interpreted as any other functional system, assuming we've got enough complexity. So you could take a rock and look at the buzzing atoms in the rock and interpret their causal interconnections. If you interpret them the correct way, you could find a one-to-one correspondence between their boxes and the boxes inside a human brain. I think this is actually correct in that at least as long as the brains can be encoded as something like a finite subset of a Turing machine, then you can argue that even, I've argued that a single particle, classical particle moving along a straight line inertially can have its positions count as encoding the states of a functional system isomorphic to us. Why? There's actually infinite data space inside the position of a particle, right? A position of a particle is described by a single real number. Real numbers go on forever. There's infinite space there. You can reinterpret those numbers as encoding the boxes of my brain. So this this reinterpretation argument suggests something really weird. So there's this view that is a very, very much a minority view, much more minority view, and much more niche than functionalism, that you may have heard of, called panpsychism. So panpsychists are really puzzled by the phenomenon of consciousness, and somehow the thought is, here's how we'll make the phenomenon less puzzling. We'll say it's everywhere. There's consciousness everywhere. Every particle is conscious. Every bit of physical reality is conscious. So consciousness is nothing special about us or other animals that are conscious, like squirrels. It's like everywhere, and somehow this is supposed to make it less mysterious. And that's kind of wacky, but maybe it's not too bad, because you could say, well, yeah, okay, but look, the particles, they're conscious, yeah, but they have such a low level of consciousness. So it's kind of counterintuitive that they're conscious, but that they have a tiny, tiny amount of consciousness, maybe that's not crazy. I mean, it would be crazy to think that the particle is like, thinking about higher mathematics or writing or reciting poetry in its mind or something like that. But that it's like, whatever, thinking about its position or something very vague like that. I don't know. Maybe that's not so crazy. But if Putnam's argument's right, at least in my version of it, you could encode all the functional functioning of your mind in a single particle. And it seems like everything around us is thinking your thoughts and my thoughts and everybody's thoughts. It just depends on the interpretation. And that seems really strange. This is like, I guess I call it something like omnipanpsychism, like everything thinks everything. So that I think is a really serious problem, because it suggests that functionalism cannot really distinguish the things that think from the things that don't think. And can't even distinguish the things that think human-level thoughts from the things that don't think human-level thoughts. Here's another line of argument that's occasionally come up. Let's go back to the little toy story about pain. Now we know that's not true, but let's do the argument first with the toy story. So, a toy story is that pain is a functional state caused by damage detection sensors leading to or motivating aversive behavior. Think of your organization's IT department. It takes in information about damage to the infrastructure, feeds it to a deciding mechanism, which weighs that information along with other information such as costs, the likelihood that somebody will find out, etc., and tends to at least produce aversive behavior. That matches the definition of pain. So, when your organization's server is hacked and IT finds out, IT is in pain. And I don't just mean the individuals in IT are in pain. They might actually be quite glad because they'll get overtime pay for dealing with the situation, right? They're not, right? But there's literally, on a functionalist, if this is the functionalist account of pain, there's literally another entity besides the IT workers in the IT department that is in pain. It's the IT department, which is a system that satisfies the definition of pain. Now, this is the standard thing you would say, I guess, at this point is, well, yes, but look, that is just a toy theory of pain. So fill it out a little bit more. We can't fill it out. So the real story about pain is presumably a little bit more detailed than the few boxes I drew, but it can't be much more detailed. Here's why. Pain seems to be a phenomenon that cuts across a lot of taxa in the animal world. Whatever boxes define pain as such on a functional story, they have to be boxes that are implemented across between us and octopi and squirrels and probably I think people think all mammals, perhaps all reptiles, probably all birds. if you put too much detail into your story, and if you just kept the little toy model I gave, I think it's very plausible that you can find across the board in the animal world, even in the plant world, which is maybe why it's a little too simple. You make it too complex, now you're starting to exclude things. Now maybe the octopus doesn't qualify, or maybe the squirrel doesn't qualify. And that's not plausible. So it's not going to be super complex, I think, as the story, if we're going to suppose that pain is had by beings other than humans. And now, I think, if we think about it, organizations really do behave rather like humans do. And rather, maybe, it's kind of infamous, right, that committees are not as smart as the individuals on them, but committees are often smarter than dogs. They're somewhere in between dogs and humans, right? Both dogs and humans feel pain. They both have the sophistication to feel pain. They both react to damage and so on with aversive behavior and with whatever extra complexity stuff is needed. Dogs have it, humans have it, probably so do committees. So I think on a functionalist view, committees are conscious. And it might even be the case that if you think about what personhood is on this kind of functionalist story, it's quite likely that a really large and sort of unified organization might actually qualify as a person, and not just in the legal sense, but literally a person, which would mean that dissolving a company could be murder, literally. And that seems absurd. Here's another worry about functionalism. So functionalism is based on the idea that there are these functional boxes with functions, right? They have rules. So an addition box has two inputs, x and y. Its output is x plus y. What's it do? It takes two inputs, adds them, whatever. Encoded in some way, maybe encoded in voltages or something. Except it doesn't, right? It doesn't always. I mean, nothing in biology works always, right? And we are biological entities. So if there are going to be any boxes in our minds, they don't always work. They sometimes don't. Now, for something to be an addition box, it can't be a multiplication box. So we want to say something like, well, so what makes something an addition box rather than a multiplication box? Now, if we're just dealing with machines, there's an easy answer to this. You ask the engineer who designed it. What did they mean it to do? Did they mean it to add or to multiply? And even if it in fact always multiplies, if the engineer meant it to add, it's an addition box, just a really bad one, right? So we have an answer there. I guess you could say, well, maybe if God made us, we could bring God in and say, God, what purpose did you have for this box? Maybe, I don't know. This seems bringing a God of the gaps solution to a problem in functionalism. I think it's actually a really serious problem, because we need to be able to define the function of these boxes, and unless we want to bring in God, and most of the functionalists, just for the record, don't believe in God, we need some way of defining their function without somebody who has a purpose for them, and that seems hard. Well, what you might try to do then is try to go statistically, right? To be an addition box is to be something that most of the time, in standard conditions, adds. What are standard conditions? Not clear. What is most of the time? I want to focus on this, what is most of the time. We could imagine like a series of critters that are more and less reliable. Maybe at one end we have ones which have this functional system that is perfectly reliable. At the other one, it's completely random. But we could imagine that all of them, in fact, that we could have a series of these critters, and they all actually end up doing the same thing. The unreliable ones just get it right by chance. The reliable ones get it right by design. The completely random ones, there's no function there. So there's no consciousness, no mind. the completely reliable ones, according to functionalism, there's mind. At some point, you're going to have a cutoff where here's consciousness, consciousness, consciousness. No consciousness here. Somewhere it has to stop. So there's going to be some kind of sharp cutoff of reliability where consciousness disappears. And that seems very ad hoc. Like, is it like 0.7 reliable, 0.3, 0.99? It seems like it would be very strange to think there's like, it kind of goes against the spirit of multiple realizability that there be this sharp cutoff like that. So I think this is tricky. How to define the reliability? Let me give one more argument. I love this one. My students actually always enjoy discussing it. This is by my friend Dean Zimmerman at Rutgers. And he makes it an argument against all materialist theories, but I'll just use it against functionalism. If I'm a machine, I'm a cloud of atoms, right? That's the kind of machine I am. I'm a cloud of atoms. I have about 300 million skin cells. For each of them, choose the least important atom in that skin cell. The skin cell would probably function just fine without its least important atom, right? And I might actually function without that skin cell at all. I probably would. There's no skin cell that's really needed for my mental functioning. Maybe if I lost them all, I'd be really miserable. My mental functioning, I'd be in horrible pain. But if I just lost one, nothing it would be noticeable. So for each of these, so now imagine this Alex sub x is this cloud of atoms, which is me, minus that one atom in skin cell x. Alex sub x is another cloud of atom from me. It differs from me. It has slightly lower mass than I do, right? Two things of different mass cannot be the same thing. So Alex sub x is not me. But functionally, Alex sub x is just like me. He's got all the same functional boxes. So he's conscious, just like me. There are 300 million of them. There are 300 million conscious beings standing right here in front of you, largely overlapping. That's fun. That's counterintuitive. Let's draw out an interesting ethical implication. There are some people in this room who are smaller than me and some people who are bigger than me. The ones who are bigger than me have more skin cells. Around them, they have more functional isomorphs sitting where they are. The ones who are smaller than me have fewer of them. So if we're thinking about like whom to do something nice to, we should do it to the bigger person because you benefit all of the functional isomorphs, of whom there are more when you have a larger person, because the larger person has more skin cells. So, in fact, larger people should have more rights, and votes should be proportioned to their masses. Maybe not linearly. I think it's not going to be a linear proportion, actually, if you think about it. This seems really absurd. This relates to the personal identity stuff. Okay, I think I will... So, this is a kind of... Sherlock Holmes says, right, that when you've eliminated the impossible, what remains, no matter how odd it is, has got to be true. It seems to me that you eliminate the physicalist options, and the only really good ones are something like biologism and functionalism. What's left is dualism, and it's strange. But it's what we're left with. Thank you.